Right. Check out the online announcement about the Information Technology Career Fair. There's a QR code to go and follow, so take a look at that and see what's up with that. It is tomorrow. Today, we're going to cover exceptions. Exceptions are problems when the code is running. All right, they're different than compile errors. Compile errors mean that you violated the laws of the language. Right? So if you said x equals 3 divided by, and that's it. That would be a compile error because you didn't follow the rules of language of how you divide. So it should be something like x equals 3 divided by 4 or whatever. So those errors show up at compile time, which is good. There's another kind of error, though, that's called a runtime error, and those are not so good. They're not so good because typically they arise under very specific circumstances. And that makes them harder to find and harder to debug and harder to test for. So what we're going to do is I've intentionally made some errors in a little test program. And then we're going to see how we can use exceptions to handle those errors gracefully so that we can continue the process to list even though there was a problem with some of the members of that list. So let's look at this file here, Java test exceptions before. So this is before we test exceptions. All I've done is I've created a list of strings, an array list of strings. I've added 2 things on it, hello, goodbye. Now, that could be any object, right? I could have a list of customers, a list of email recipients, like we did last week with the interface. But we're going to go and we're going to try to produce those. And I have a couple problems that are coded in this. Number one is if I is equal to 1, I'm going to null out that field. All right. Let's do that here instead. So what that means is by the time when we run this loop, we'll be able to run where I equals 0 because there's an object in that position. And we'll be able to print out hello. Actually, we'll be able to print out the length of hello. But when it goes and tries to run where the subscript equals 1, there is no object in that position. Now, you may have talked about null in database classes or whatever. A null is different than an empty value or a 0 value or anything like that. A null means that the object just doesn't exist. It's not like it's not like a string that exists with no characters in it. It's that like this. This is a string that exists that has no characters in it. That's not a null string. A null string is what we're doing here, where we have taken element 1 of this array list and set it equal to null. All right. So we've gotten rid of this entry and we've replaced it by a non-existent string. String that doesn't exist. I mean, that sounds a little spacey maybe, but that's what a null is. An easy way, the way I always think of it is like you could ask me what my account balance is at KeyBank. All right, I have an account at KeyBank. Maybe I had a wild weekend and I spent everything in my bank account. All right, in which case my bank balance would be 0. All right. So my bank balance is 0 because I have no money in my bank account. That's different than asking me, what is my bank balance at, say, Lorraine National Bank? Well, I don't have an account there. I can't really say my balance is 0, right? Because that's not an accurate statement. Really, if you're going to ask about my bank account at Lorraine National, it's null. It's non-existent. So what we're doing here is I'm adding 3 elements to this array list, element 0, 1, and 2, and I am blanking out, nulling out the element in position 1. So I'm nulling out this one. Then I have a loop that's going to go from I equals 0 to 100. And I'm just going to print out the length of the string. That's what this is doing. It's looping through and it's grabbing each string in turn. And it's printing out the length. Well, when it gets to this null object, it's going to be a problem. What's the length of a string that doesn't exist? Well, this sounds like a philosophy class all of a sudden. It doesn't make sense to ask that question. All right. Therefore, I'm going to get an error when I hit this element 1 in the array list. So let me go and save this and compile it. And run it. And sure enough, I get what's called an exception. This is an exception that you might have seen before. If not, I guarantee you'll see it again if you do any kind of programming, any more programming after this class. You might even see it in your C# classes because C# was modeled very closely after Java. It's saying that it went through the loop, it started the loop, it went through when I was equal to 0 and printed out the length of hello. That's 5. It then tried to print out the length of that null string in position 1, but it couldn't. Therefore, it gets an error and it throws an exception. Notice it stops at that point. The program has blown up. This is a runtime error. Now, let's imagine that this was a list of customers, a list of thousands of customers, and we wanted to process their bills. And for some reason, there was a problem with customer 10 on the list. We would try and execute and do customer 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When we hit 10, if there was this kind of problem, the program would terminate and you wouldn't process any more customers. Well, that's not a good thing, right? Just because there's a problem with this customer, let's say, or this string, doesn't mean that we want to stop processing. All right? So therefore, what I'm going to do, what I need to do is I need to test for this kind of exception to occur. All right? And I need to display, do something with this exception. Now, sometimes there's not much you can do with an exception. Like this exception here. If this was a null customer, let's say, instead of a null string, how do you send a bill to a null customer? You can't. But I could write to a error log that says I was not able to process, a customer, and then I could do some investigation to figure out why I wasn't able to process a customer. Now, even if I don't get rid of, or even if I don't null it out, I'm going to get another problem because I'm running this loop from I equals 0 to 100. And as you can see, there's only 3 elements on the list. So I'm going to get a different problem when I try to access element sub 3, or the 4th element on the list. And that is index out of bounds exception. Index 3 out of bounds for length 3. In other words, I'm looking for index sub 3, and the length of the array list is 3. So the values for the subscripts are 0, 1, and 2. So this tells me that there is that problem. Well, this is not a good way for the program to terminate. All right. Now, let's think of other examples of things that we wouldn't want to process, things that there would be errors with. Later on, when we talk about user interface, all right, maybe we're ordering pizzas and we ask for how many pizzas do we want to order. And I type in characters instead of a number. Well, you can't process if I typed in XYZ for the number of pizzas I wanted to order. That's an error, right? It's going to try to convert that into an integer and it's going to blow up. Well, I don't want my whole program to blow up. I want to display a nice little error message that says, hey, you had a problem with the value that you entered for number of pizzas. All right. Likewise, there's only 3 possible values for the crust, right? Or 2 possible values for the crust, I think, thick and thin. What if I tried to enter something else? All right. We can build an exception for that, to look for it and throw the exception. Now, creating exceptions is one thing. We've created exceptions here. We have to know how to handle them. And you probably have seen this in other languages, maybe in C#, but this is where we use a try-catch block. So I'm going to look at the second version of this little test scenario. And this has some error processing in it. So, make the same modifications I did to it. And I put the statement I want to try in a try block. Try. I then have catch blocks for each error that I'm anticipating could happen. Well, I kind of rigged the deck in this case, right? Because I wrote this with some problems in mind. So I know what errors it's going to generate. One error it's going to generate is a null pointer exception. All right, at position I. So in other words, when it hits position 1, that has been nulled out. I'm going to do it like this. That has been nulled out. Therefore, this is going to be asking for the length of a string that doesn't exist. It can't do that, of course, so it's going to throw an exception. I'm then going to catch that exception, and I can do whatever I want. In this case, all I'm going to do is I'm going to output that there's a null string at such and such position. Now, here's the good news. It's not going to blow up because I've handled that exception. Someone has to handle the exception. Either you handle it in your code or the Java runtime engine will handle it by blowing up your program. Someone has to deal with it, the exception. So it's better for you to take control, and any commands that you think possibly could get an error, put those in a try block and catch the exception and do something for it. In this case, if this is the exception that occurs, I'm going to output this. If this is the exception that occurs, if the index is out of bounds, in other words, I try to refer to subscript, 5, 6, 7, 8, 9, 10, and whatever, it's going to output invalid index at position. But the nice thing is it's going to continue running. It's not going to blow up. It will run to completion. So let's look at the output of this example. So I do my compile and I run test exceptions. All right. What did it do? It ran a completion. It went through all 100 iterations through that loop. It outputted the value of that first string, the length of that first string rather, which it was hello, so it outputted 5. The string at position 1 we set to null, and therefore it gives me a nice clean error message that you can understand. Null string at position 1. It gives me the length of this string, which is an empty string, which is 0. And again, here's the difference between an empty string and a null. This is a string object that I'm adding to this. It's a string object that contains no characters, but it's a valid string object, as opposed to a null string object, which means an object that doesn't exist. I set that equal to null. So it can tell me, hey, the length of that is 0. And then the rest of the way through, it gives me this error, invalid index of position 3, 4, 5, 6, 7, 8, 9, 10, 11, whatever. All right. Now let's imagine this on more practical or more real life terms. Again, imagine you're processing a list of employees, their paycheck. All right. And every paycheck, every employee is supposed to fill out, what's that form? A W-4 form, I think it is. W-2, you're right. You're right, W-2. So everyone has to fill out a W-2 form, right? Well, what if one employee didn't have a W-2 form filed? And we tried to read that information and it didn't exist. All right. So we tried to create our W-2 object and there was no W-2 for that employee and we get an exception. If we didn't handle that exception, it would blow up at that point, and it might even be it would not even be clear, hey, which employees did we process, which employees didn't we process? Hey, the people after that employee in the list of employees, oh, they're not getting a paycheck now, right? Because the program blew up. A lot of potential for problems there. Instead, what we can do is we could look and see if that object is null. We put that code in a try-catch block. And if there's a null W-2 form for that object, for that employee, we can catch an exception and write a neat, tidy little error message that anyone could understand. Here I'm just outputting it to the console. In a more realistic case, I might create a report, right? Create an output file that I could write to that would show like which employees I processed and what I printed out for them, and which employees didn't process because there was errors. But the point is I can loop through all of the items in that list Again, in this case, even though there's only like 2 items in the list, but I don't terminate just because there was a null object in there. I can choose how to handle it and not let my code blow up. That's a big thing. All right. So what about the object? This is with just any old object, right? Any object that is out there could be null, right? And any array list could have a invalid index at position. Now, in this case, I looked specifically for these two problems. Maybe I'm not sure what kind of exception I'm going to get. In which case, I could catch all exceptions. And I can't say specifically what the problem is, but I know there's a problem at position I. So if I do this, I'm doing the same thing for each kind of exception. And because I'm looking for exception. Fortunately, that exception itself is an object. So we could actually concatenate E to string and get the string representation of that object. And it tells us that at position 1, the problem is a null pointer exception. In position 2, index out of bounds. Which method should you take? Well, it depends on your particular problem. If you're going to process all exceptions the same, you might as well just catch exceptions. If you're going to do one thing, if it's this kind of exception, another thing, if it's another kind of exception, then maybe you would differentiate and catch specific exception types. But there's more in the exception object if we need it. Let's look at the Java docs for the exception object. We can get the stack trace. That's a very detailed. We can print the stack trace. Let's do that. That will give us even more information about the error. Gives us a whole bunch of information about the error, including like what line of code caused the error, line 14, and all of the different functions within the Java built-in classes that got called in the process of getting this error. So we have this error exception, this exception object that we can do a lot of things with. So toString is just one of them. We can get other things as well. Let's look at this one, init cause. I actually don't know what this is. I'm thinking it's the line in the program where the error started. Well, that must accept an argument that I'm not supplying. And that's what that means if you get this error. Actual and formal argument lists differ in length. I'm not giving init cause a argument, and yet it expects one. Let's see what it expects. Oh, this is when you chain exceptions together. So just forget what I said the last couple minutes about the init cause. It's something different than I expected it to be. All right. So what progress have we made in our desire to write better programs? Well, we've been able to catch certain kinds of problems, and certain kinds of problems that we can sort of anticipate. If we're dealing with a list of objects, we can almost imagine it's possible something in there is null. All right. So we could put our processing of that list in a try block and catch for null object pointer. All right. Now, in this case, obviously, I engineered that problem to happen. So, but in the real world, still, if you're dealing with a list of objects, there's a possible that one of those objects is null. So therefore, you could put code in there to make sure that one of them is not null with a try catch block. We can either catch any exception and do something, or we can catch specific kinds of exceptions and do things. Again, these apply to any objects, null object exceptions, and so on. What about the custom objects that we build? So for example, our pizza object or our order object, right? We want to make sure that the name isn't blank when you order a pizza, right? We want to make sure there's a valid name. We want to make sure there's a valid phone number. If it's delivery, we want to make sure there's a valid address. In other words, you can't have a blank address field. If there's a quantity of pizza ordered, we want to make sure that that number is a positive number. If there's certain kinds of crust, we want to make sure that that right kind of crust is ordered. Now, you might ask yourself, do I need to throw exceptions? Do I need to process exceptions if I put validation in my user interface? And the answer is, yes, you do. So to simplify things, let's say I have my order object that contains a list of pizzas. I could have my desktop application that allows me to create orders and create pizzas. Maybe this is in each store. You know, each store might have a PC or something, or a cash register that runs a Java application. Maybe I have a web application where my customers can order pizzas. Maybe I have a mobile application that I can use to order pizzas. Where is it better to do the validation? Well, if I put the validation in each user interface, I'm liable to forget one of the user interfaces, or a new user interface is created, you know, because we've developed our mobile app and we didn't include the proper validation. Or maybe we're validating inconsistently, or any number of things. Therefore, it's better to put the validation in the order and the pizza object itself, so that any user interface or any other program that creates these objects, that validation is going to take effect, because you can't create an order without going through that validation. Because of where that validation exists. That validation exists within the object. Now, we haven't covered GUIs yet, but we will soon. I think we will cover them next week. We'll start covering them. Remember, our test class is sort of a surrogate GUI for us. Until we get around to writing GUIs, we are going to use that. So let's say I have a triangle class. I know this is a silly example, but you know, it gets the job done mostly. There's actually a bug in this code, but we'll talk about that later. Now, if I create a triangle, triangle has three attributes, right? It has side 1, it has side 2, and it has side 3. Now, there's some rules about a triangle, what makes a valid triangle. One of the rules is that the length of the sizes need to be a positive number, right? I can't have a triangle that is 0 length for side 1, 10 for the length of size 2, and 8 for the length of size 3. Doesn't make sense if one of the lengths is 0. And it makes even less sense, if that's possible, for the length being negative. So I know that my triangles have to have a positive value for these integers. And I'm making them integers, so they need to be a positive value for these integers. There's another rule with triangles too. We put this up in Paint again. No matter the triangle, the sum of any two sides is always going to be greater than the third side. So A plus C is always going to be greater than B. Can almost prove that to you intuitively. If I could get to this point, from this point, what's the shortest distance to it? Straight line, right? That straight line is B. If I could get from this point to this point by going from A to C to B, if that was less than the length of B, then the shortest distance between those 2 points wouldn't be a straight line. And we know that that's not correct in planar geometry. All right. If that didn't make sense to you, don't worry about it. Just trust me, all right, that this has to be true. So if I have a triangle that is 10 for one side, 2 for another side, and 3 for the third side, that's not a valid triangle. Whereas a triangle that is 10, 8, and 7, yeah, that is valid. 10 and 8 is greater than 7. 10 and 7 is greater than 8. 8 and 7 is greater than 10. So yeah, that's a valid triangle. I can create exceptions of my own in my own classes. All right? I can do that a couple different ways. Here is one way I can do that. When I create the triangle, I say my constructor might throw an exception. If there's code in a class that throws an exception, either that class has to handle it or it can throw it up to whoever called it. All right? In this case, my unit test object calls my triangle class. So therefore, I'm going to throw the exception back up to the unit test class and let it handle it. Remember, our unit test class is a replacement for a GUI. So if you think about it, we want the GUI to handle the exception, right? We want the boss program to handle the exception and decide what to do with any exceptions. So this is going to call set side 1. Why doesn't it just say side 1 equals arg1? Well, because that would be circumventing the exception processing that we have in set side 1. What does set side 1 do? Well, it might throw an exception if the argument is less than 1. So if the argument is less than 1, it's going to throw an exception. And that exception, in turn, is going to get thrown by the constructor. And finally, the unit test class is going to handle it. And the same thing for the other sides. That's why, if you remember a while ago when we were talking about constructors, I said the constructor shouldn't set values itself. It should call the set methods to do that. Because then I could put validation in those set methods and throw an exception anytime that is wrong, not a valid value. What's more, I test to see if one of these 3 conditions is true. This simply means or. So I'm seeing if side 1, if side 1 is greater than side 2 plus side 3, if side 2 is greater than side 1, the whole thing that I talked about in this paint file. If any of those things are true, then I got an exception. This is me putting exceptions being thrown in my own code. Previous example showed me catching exceptions that the built-in Java classes might throw. Here, I'm throwing the exceptions and handling the exceptions. Let's look at the unit test. My unit test class. I put these in a try block. Right off the bat, I have a problem because I can't make integer out of the word hello. That's going to throw a number format exception. So let's try this. Integer, by the way, is sort of an object version of an int. You need things to be integers so that they can be put in an array list, for example. Java is nice enough to convert between integers and ints. And that's called boxing and unboxing. But at any rate, I'm going to try to make an integer out of the word hello. Obviously, that's not going to work. It's going to throw an exception. And this is the exception it's going to throw. Why does the compiler not know that that's a problem? Well, because there is a function, there's a constructor on integer that takes a string that has the value of the integer. So it doesn't actually evaluate that string. It just says, okay, that string, yeah, there's a function that accepts that. So let's compile everything and test. And it tells us number format exception for input string hello, code specifically written for number format. I could change that to 5. And it'll work. But guess what? That's still not a valid triangle because 5 and 1 is less than 8. Each side must be less than the sum of other sides. Now, the last exception here is sort of a catch-all. So sometimes if you're writing code, you may anticipate certain exceptions. There's other exceptions that you might not anticipate, but you want to allow for the possibility that they'll occur. So you define your specific exceptions up here and define a catch-all at the bottom that's going to catch and it's going to process it. And in this case, I got an exception when each side must be less than the sum of the other sides, but I didn't write code specifically to catch this exception. It threw the generic exception. Same thing would happen if we tried to give a -1. Again, side 1 is invalid. I'm not sure why I'm getting this error or this warning for deprecated. Recompile with a -x lint for more details. So let's do that. Oh, it's telling us that this is deprecated. Deprecated means that instruction is going out of the language. So it's okay to use it for now, maybe, but There's probably a better way to do it that is not going to go away from the language. We'll not worry about that in this case. Now, I have one other example here of exceptions that we'll look at. And that is where I can actually create my own exception objects. And I can use inheritance to create a class called triangle exceptions. Because maybe I would want to do something different for a triangle exception than another exception. Again, I know companies don't write applications to process triangles, but maybe a customer, all right? So I could define this as a customer exception, or in our case, a triangle exception, and it inherits exception. It extends exception. Then what I can do is I can write test code to test to see, is it a triangle exception? Now, the reason we differentiate again is so that we can handle things differently, depending on the kind of exception. What's that throw? So again, the exception comes from the triangle. So I know specifically that this is a triangle exception and not just any other possible exception that might exist. The reason we separate things into their own exceptions is if we want to do something different with that kind of error. And again, in this case, I'm just outputting a message. Depending on the particular problem and the particular program, you may do all kinds of things. With a GUI application, what are you going to do? You're going to display a message on the screen and tell the user to re-enter the values. If I had a GUI that, for my triangle maker, where I typed in 3 sides and it gave me an error, I would display a message on the screen. If it was a batch process, processing all the triangles in my database, all right, it would look for an exception and maybe write it to an error log that I could examine after I ran my process to see what didn't work or something along those lines. All right, go through these examples. Let me know if you have any questions. Your next assignment, I believe, concerns creating exceptions, I think, for the pizza case. I think. That's why I didn't use that as an example here. All right, if you don't have any further questions, that's all I had today. We will see you either next week or possibly up in lab, either in person or virtually.